All right, so let's start with cloud computing. So cloud computing is basically using remote servers which are hosted on the internet to utilize different computing services, which are, for example, servers, databases, networking, security, all of this stuff. So you're paying as you go, and you're storing and accessing data whenever you need them. Now there are different benefits to cloud computing. The first of which is like speed and agility as to how quickly you can provision your computing resources, which is like under minutes. This data can be accessed over the globe, anywhere in the entire world. The data is okay. So you are basically saving a lot of cost because you don't actually have to buy a physical hardware and you have to manage that physical hardware, but instead the cloud providers are giving you an easy user interface to interact with your hardware. So your costs are basically being saved up, and also the fact that you can scale up and scale down with your requirements and with your needs. You have better security because you're not responsible for managing the security of your databases. You have better accessibility, right? So I've talked about this. There is no single point of failure, there's high availability, and you're paying as you go. You're also maximizing your server utilization by implementing automated provisioning. What is cloud computing architecture? So the way how you're going to design a cloud computing architecture is that, first of all, you're going to need a front end through which the client can interact with your cloud interface. Second is going to be some sort of a back end which is going to be responsible for your databases and servers. Third is your networking to route your IPs, and the last is going to be your cloud-based delivery model, which is going to be either IaaS, PAAS, or SaaS. We're going to talk about what is these. What are the benefits? The benefits are now that you don't need on-premise server and storage because you're just using cloud storage. Instead, you're reducing the need of IT data centers, and again, the same point that you don't actually need IT data centers or real estates or cooling and power and managing all of that stuff because everything is being done for you. um, it accelerates the delivery of new applications. You can utilize Kubernetes and Dockers to modernize your applications. You can ensure compliances, security principles into your applications. You can cut costs and prevent security breaches. There is fast provisioning, which I talked about, and there is real-time scalability. Now, there are different service models, so note that there is a difference between delivery model and service model. Service models sorry so delivery model and service model is the same thing. Deployment and service is different. So first we're going to talk about service. In service, we're talking about software as a service. So in software as a service, we're basically saying that cloud provider provides cloud services which are ready to use applications which could be accessed via web browsers without the need to deploy the software on servers, which basically means that these cloud providers are giving you ready-made applications which you can use anytime you want, and you don't actually have to deploy any application on a server for it to work. So an example could be using Gmail or using Google Docs or using Microsoft 365 or Microsoft Office. So these are basically ready-made applications which you are utilizing, and you don't actually have to manage or create or install these applications on your end. So the benefits is that it's reducing the cost and time to install and manage a software. It can be quickly be deployed. The quickly deployed basically means that you're basically utilizing them. It's very simplified data management. Okay. Um, the cloud provider is responsible for managing. Yeah. So the cloud over here, it's the cloud provider's job to basically manage the hardware and the software and the OS of the application. You're just responsible for um, just how you're going to use the application. Now in the past model, which is platform as a service, over here now you're now allowing more access to be given to the user. um, Unlike before, over here, since the cloud provider had the access of the OS, now had the access of the OS and the application. Over here, now you're giving the access to the application to the user. So cloud providers provide a computing platform, a fixed OS, where users can create and manage their applications. So now they can create their own applications in their own environment. That environment could be a Python environment, a C# environment, a Java environment, and you can do all sorts of things. So they're providing you a fixed operating system on which you can do all sorts of your development, testing, and deployment and all of that stuff. But the cloud provider is still responsible for the OS and for managing the hardware. So the benefits is that it has high availability and scalability. It has reduced coding time because you aren't concerned with the OS and the underlying structure as to how the infrastructure is communicating with the OS and as to how it's basically being utilized for your application. You're just concerned with how you're going to write your application. It has automated business policy, and it's easy to migrate to a hybrid model. So I'll just read these things out. Cloud providers provide a computing platform, a fixed OS where users can create and manage their applications. It gives your development tools, languages, environment. It's easily scalable, integrated databases and servers. The last is the IaaS, infrastructure as a service. This is the most popular one, which is being used by Azure and AWS, because in this one, all of the benefits that we were talking about cloud computing comes from over here, because over here now you're giving even more access to the user, and you're saying, okay, you can do whatever you want. You can create your own virtual machines. You can create your own OS, not create your own OS, but utilize any OS given by the cloud provider. For example, you can use Linux, you can use Windows, you can use Macintosh. You can create all sorts of machines. Do you want sorry, not machines, but all sorts of like applications on that virtual machine. You can use any processors, any GPUs, which are being given by the cloud provider. So you have complete access towards your network, your security, your entire infrastructure. So again, you're not managing the hardware on your own, but the cloud provider is providing like a user interface for you to interact with the hardware. So it's a rental service, which is basically it's a pay as you go model. The more you're going to use or utilize their resources, the more you're going to pay for them. Okay, so multiple users are available on a single unit, so it's a multi-tenant system. Okay, so the benefits are the same thing over here. An example is AWS and Azure. Let's move on. Deployment models. So there are four different deployment models. The first one is public cloud. So public cloud basically means that you're basically deploying your application on the public. It can be accessed through everyone on the public. And basically, if you're allowing your application to be on the public, then there is going to be security threats. So that's one of the disadvantages. The advantages is that it's very cheap to use, it's very easy to use, and you can integrate it with different applications and different services. So I'll just read this out. Allows deployments on public cloud, which is easily accessible to the general public. It is less secure, but is cheaper. Its services are delivered via the internet. I think it should have been its. Okay, so when to use. Predictable computing needs specific number of users. So you actually know how many users are required for your application, then you're using that. Apps and services required to perform IT operations, elasticity and scalability. So whenever you want elasticity and scalability, you have a fixed number of users, you already know how many users you're going to get, then you're going to use public cloud. But in the cases where you don't know how many users you want, in that case, you will be using private cloud because you have more control over here. So it allows systems and services to be accessed within a single organization. It is more secure because in private cloud, you're basically saying no third party, no public is allowed to interfere with the application which is being made in the single organization. So you can imagine it like this, that you have your application being built inside a private network which is connected to some sort of on data or on premises on-premises data center, which is your company's or your organization's private data center, which is being communicated with this application, which is also in a virtual private network through a VPN connection. So that is basically the whole gist of private cloud. So what advantages does it does? It basically provides you with your own personal on-demand email services if your organization has one, on-demand databases services. It's very rapid because it's only in the private cloud. You are going to be using this where you want your system to be very secure. You want to have there's some certain compliant issues or compliant rules which have to be met. You want strong control over your entire IT operations and security, and you want high performance and available technologies. So this is used for highly regulated industries and government agencies. Then you have community cloud. So you can think of community cloud as a multi-tenant system in which they're like, unlike in private cloud where there was only a single organization, in community cloud there are multiple organizations which are communicating with each other. So I'm sorry, I don't have space over here, but I'll just draw it over here. So you can imagine that there's this organization 1, there's that 2, that's 3, and that's 4. And all of these are communicating with one another. And it could be possible that maybe this organization has some resources which are being shared amongst all of the other resources or other organizations. So a very good example could be that your teacher is uploading some content on Google Classroom and multiple students can then access those resources. So that could be a kind of like an analogy to community cloud. Another example could be that maybe your university provides some license or some license towards viewing different certifications or videos on Coursera, or it gives you licenses towards different paid courses. So that would be a community cloud. Okay, the last model is the hybrid model, in which it is basically the mixture of both your public and private. So for the critical services, you are using the private cloud, and for the non-critical services or activities, you're basically using your public cloud. So apps and data workloads can be shared. Apps and data workloads can share resources between public and private. So basically, if you have different services in your application, some of them could be used in public, some of them could be used in private. So their workloads are being shared. So when would you use them? When would you use a hybrid model? So you would use it when your organizations are serving multiple verticals, which means it has varying regulations, security, performance, demand. So it has varying regulations, different security rules, or different performance demands. Then you would use that. If you want to optimize your cloud, public cloud services such as SaaS. So basically, when we were talking about SaaS, we were talking about ready-to-use applications, which are mostly public. But if you want to convert them into private, then you would be using a hybrid model. If you want to improve your security, then you're using this. You're optimizing your cloud investment, which is basically best of both worlds. This basically means that you're using public to its maximum capacity and you're using private to its maximum capacity. Dynamically changing to the best cloud model. Example: Netflix pay-to-go subscription model. Load increases when a new hit series debuts. So what this basically means is that maybe when you go to Netflix and it's running on a public model, but when a new trendy movie is uploaded on the Netflix or the new series debuts, then there might be a very high a very high rise towards its traffic, and then Netflix could switch to a private network through which it could now allow more more users to be accessed. So uh, now there could be a confusion that you might be thinking as to like, how can you allow users to be viewed on a private network, right? So what I mean by this is in terms of the storage. So what if Netflix was using a public storage for the normal use because that's more cheaper, but when it has a very high stress on its servers, then it would start to use its on-premise data centers to accommodate the workload. So that's what I mean by that. Okay, so what are the benefits and disadvantages? So the benefits of public is that one, it doesn't have maintenance costs. Two, it's flexible because it's very cheap. Three, high scalability and flexibility. And four, reduced complexity because it's very easy to use. Private because it's very secure. Second, regulation compliant. Three, highly scalable for unpredictable demands. So while I was giving the example of Netflix, that was what I was referring to. And four is your efficient performance because, again, since it's a private network, it's going to have very high performance. In hybrid, since it's the best of both worlds, so you're going to say that this is policy driven, it's very highly scalable, flexible, it has high security, and you can also have workload diversity, which basically means that it's very highly reliable. The disadvantages is that in public you have minimal control. Second is that as you're scaling up, the prices tends to increase in an exponential rate. So it has potential to have a very high TCO stands for total cost of ownership. Yeah. And then it is also very less secure. In private, it's very expensive. We did talk about as to how secure it was, but that security basically means it is expensive. When you're using your own data center, then it could be possible that most of the times it could be underutilized, or it could be the fact that you have so much money to be used for buying your infrastructure or your hardware. So there is some sort of like a capacity as to how much you can buy because of your limiting budget. And you also have minimal mobile access because you don't want every device to be connected to your private network. In hybrid, it's more complex because now you're dealing with both public and private. It has issues with compatibility and integrations. And again, since you're using public, then it could be that you could have a potential for high TCO, which is high cost of ownership. So again, let's just review it very quickly. Benefits, for public, you don't actually need any maintenance cost. It's very highly scalable, flexible, and that you have very flexible um, pricing. And the fourth point was that it has reduced complexity. For private, it is very secure. It is aligned with your compliances. Um, it is very efficient and it is highly scalable when you have unpredictable demands. For hybrid, it's policy driven. It divides your workload. It is highly scalable and flexible, and it's very highly secured. For disadvantages, public has minimal control. It is going to be less secure and it has potential to have high TCO because of scalability. Private, it's expensive. Um, Sometimes your resource is going to be underutilized. Sometimes you don't have money to upgrade your resources, and sometimes you're going to have minimal mobile access. For hybrid, it's very complex to use. It has compatibility and integration issues, and it has potential of high TCO. All right, so that was the entire gist as to what is cloud computing and the introduction of cloud computing. In this video, I am going to touch about different microservices in cloud, but I'll be explaining as to what are microservices in the next video. So to give a basic gist as to the different microservices that are available on the cloud, first of which we are going to be talking about is going to be the compute services. So computer services is basically talking about, in this context, is going to be virtual machines. So containers are basically AWS EC2 or for Amazon, and Azure for Microsoft container. Is it allows you to easily run applications on a container or manage clusters of Amazon or Azure. So you can think of it as like your virtual machines on which you can like run your applications on. It has high performance container management service, and it supports Dockers as well. In serverless, you have AWS Lambda, whereas in Azure you have Azure Function, which basically is used to now run without provisioning servers at all. In this, you just upload your code. The code runs on its own. It scales up on its own. Everything's being handled by the AWS and Azure on its own. In storages, if you're using caching, then for that you will be using AWS Elastic Cache or Elasticache, and for Azure it's going to be Azure Cache, so it's for fast retrieval. And if you want to avoid using slow data access rates from the database. For object storage, you are using Azure Blob Storage, and for AWS, it's the S3 bucket, which allows you to have highly reliable and scalable objects sizes, which can be of all sizes. So it for the S3 buckets, you can have unlimited objects. In databases, if you're using NoSQL, then you have S3 DynamoDB, AWS DynamoDB, and for Azure that is DocumentDB. If you're using relational DB, then for that you have AWS Relational Database, and for Azure that is SQL Database. So that's for choosing SQL databases. It gives you different options. So for example, it gives you to choose from Oracle, Postgres, Microsoft SQL, and Postgres SQL. In networking, for load balancing, you have AWS Elastic Load Balancer and you have Azure Load Balancer. So the balancers works in two ways. One is at the application level, which handles the HTTP and HTTPS requests at app level, providing request routing to containers and microservices. The second is network load balancers, which is basically on the network level, and it is handling millions of requests per second with ultra low latency. So it's basically allows you to route connections to different microservices. So this is for balancing your HTTP and HTTPS traffic towards the containers and microservices at the application level, and this is for your network level. Then you have service discovery, which is AWS Cloud Map and Azure DNS Discovery. So basically through this you can define custom names to your resources, to your app resources, while maintaining your updated location of dynamically changing resources. So for example, you're using some EC2 instance, you can call it whatever you want to do it, and then as its IP is being changed, its location is also going to be changed, and everything is going to be maintained by this service discovery. So AWS Cloud Map and Azure DNS Discovery. On this topic, we also have DNS, AWS Route 53, and Azure Traffic Manager. This is basically maintaining your DNS to efficiently connect requests to the infrastructure that is being running in the AWS and Azure. So any resources that you're using, that has to be connected to the AWS and Azure's infrastructure. So for that, you're basically using AWS Route 53 and Azure Traffic Manager. So it can be used for IP health checks and service discovery for microservices, which I was talking about over here. Then you have the service mesh, which is AWS App Mesh or Azure Service Fabric, which is basically monitoring and controlling your microservices running on the cloud. Mesh services standardizes how your microservices communicate and gives end-to-end visibility and ensure high availability. So it's basically controlling how your microservices are working, and it's ensuring that you always have high availability and visibility from one end to the other end. So yeah. Then you have API proxy. For API proxies, for creating APIs, you have Amazon API and Amazon API Gateway, and for Azure, that is API management. For messaging, you are using AWS Simple Notification Service. For Azure, that's Azure Notification Service Bus. For message queuing, you're using AWS Simple Message Queue Service, and that's Azure's queuing service. So this basically allows you to like easily decouple and scale microservices, different distributed systems and applications. For logging and monitoring, if you're doing it on the API level, then you are going to be using AWS CloudTrail and Azure Operational Insights. Whereas if you're doing it on the application level, then you will be using AWS CloudWatch and Azure Application Insights. For a more detailed analysis, you're going to be using distributed tracking, which is going to be AWS X-Ray or Azure Monitor for end-to-end requests as they travel through your application and see map of your application's underlying component. So basically, as to how the requests are being traveled from one end to the other end, and if you also want to see the underlying components of your applications, then you're going to be using distributed tracking. Then for DevOps, you are using container for container image repositories. You're using AWS's Elastic Container Registry. For Azure's, that's Azure's Container Registry. If you're using continuous delivery, then you're going to be using AWS Developer Tools or Azure Developer Tools for building, testing, and then deploying your application. So for compute services, if it's container, you're going to be using AWS EC2 Elastic Container and Azure Container. For serverless, that is going to be AWS Lambda and Azure Function. For caching, that's going to be AWS Elastic Cache and Azure Cache. Object storage is going to be Azure Blob Storage and AWS S3. For database, NoSQL, that's going to be AWS DynamoDB. Azure is going to be DocumentDB. For relational database, it's going to be AWS relational database, and Azure is going to be SQL database. Networking is going to be just AWS Elastic load balancer, which is at application level and network level. So for the containers and microservices, HTTPS and HTTPS requests at app layer for app load balancer, and for network, there's going to be the network load balancer. Then you have service discovery. For that, you are using AWS cloud map and Azure DNS discovery. Then you have service mesh, which is going to be AWS app mesh and Azure service fabric. API is going to be Amazon API gateway, Azure API management, AWS route 53, and Azure traffic manager, simple notification service, Azure. Yeah. Yeah, so I think that is all. Looking forward to the next video now.